Malthi. And as you know, we kind of started with live webinar series a couple of months back. And this is the third session we are doing as part of the series where we kind of invite experts and practitioners and talk about one of the most important topics, especially which is of relevant for product builders, product engineers, right? And today is one of such a session where I have invited Shamsher Ansari. I got to know about Shamsher through his Substack newsletter and a lot of bunch of really interesting stuff that he posts on his LinkedIn. So Shamsher, feel free to share also your LinkedIn
Yeah.
link so that people will know where to find you.
Yeah.
So
Sure.
some interesting aspects, right? While a lot of us, when we talk about AI and LLM, it is more around just the application part of it. But I think what I've been when I used to read Shamsher's newsletters and when I chatted with him is that he's somebody who kind of understands the entire stack, right? And you need to understand between the traditional products or the non-AI products and the AI products, there is a complete changeover in the way the product lifecycle is, the way the tech stack looks like. There are many more newer nuances, understanding the GPU, understanding how the whole processing of prompt to the answer that you get, how does all that works. And the most important thing, especially for a product builder, is that it also changes the cost and the ROI lens. And today, if you look at it, you pick up any, whether it is a PwC, it is a EY, any of the consulting firm, one of the biggest question that they have is that are companies finding ROI in their Gen AI projects or not? Right? And those are some of the important aspects that we are going to touch upon along with Shamsher today. That you, as a product manager, as a product builder, how do you kind of put that critical lens when you are looking at it? So give you a little bit more introduction on about Shamsher. He's a group product manager at NeevCloud, and he leads the product strategy for India's GPU-powered Supercloud. He's driving initiative in AI infrastructure, making large-scale GPU compute accessible, efficient, and developer-friendly. He has more than a decade of experience in cloud, AI infra, and edge computing. And he talks a lot of things around SLMs, LLMs. If some of these terms are going to be new, you don't have to get nervous about it. We will kind of touch upon a lot of these things. And prior to NeevCloud, he has spent time at VMware and Red Hat. And he's somebody who's extremely passionate about advancing GPU powered AI platforms, open source collaboration, and I think the most important, simplifying complex technologies for developers and enterprises. Right? So I will not take away the thunder. And before we get jumped into this discussion, a little bit about myself. My name is Malthi. For folks who know, I come with about 25 years of product development experience, product management, and now I work with startups to help build their AI product strategy. Again, a very complex path which companies are trying to figure out how do we get started on this AI journey. And I also train AI product management courses and also the host for Product Talk with Malthi. With this, I'm going to hand over the mic to Shamsher to get started. And guys, please feel free to keep asking your questions on the chat. You can access it on the Riverside app. So please keep your questions coming. And Shamsher, I think what we would love to understand is that I think there could be a bunch of folks who probably really do not understand what is really LLM inference.
Right.
So if you could kind of help us simplify that, unpack that a little bit for us, and then also talk about that, how does that make a difference in the cost and ROI of an AI project? I think that would be a great way to get started.
Absolutely. So first of all, thank you for having me. And I think instead of just talking, I will prefer to use some slides, and mostly it will be a picture so that you understand and you build some image in your mind and think about how this LLM inferencing and AI works, right? So I'll quickly share my screen and start because generally in podcasts people just talk and then the audience get disconnected because we are talking and they don't know where the direction is going and all of those things. So I prefer showing some pictures to explain what I'm trying to say. So I'll quickly share my screen
Sure.
and
And
then
also, if you could just increase the volume a little bit, I think
yeah,
so far you're okay. Now I see a little bit of these things.
sure, no problem. I'll keep the mic close to me so that
Sure.
it's properly audible. So I hope this is good. So now my camera is here, my monitor is here. So I'll sometimes look at my monitor just to make sure I'm on the right thing and I'm explaining the right thing, right? So yeah, hello folks. My name is Shamsher, and I think you've already got the introduction from Malthi, so I don't need to go through the same again. So what I'll do, I'll just quickly jump into explaining what LLM inferencing is, and then we will talk about how does it affect the cost. And if you're a product manager building AI products, then I'll try to explain how do you calculate and understand the ROI of your AI products, right? So I work as a group product manager at NeevCloud. I lead a product strategy for India's AI Supercloud. That's what we are saying it, and I think we are building a lot of exciting products. You will get to know a lot of exciting things related to GPU, AI inferencing, LLM training, and all of those things. And at the end, I think I'll show you a quick demo of AI inferencing just to make sure that whatever we are learning in this session will be translated into actual product, right? So before we start going into explaining what LLM inferencing is, I want to understand which is your favorite chat tool or chatbot tool or AI tool, I would say, like ChatGPT, maybe Gemini or anything else. Please feel free to comment on it and just mention why it's your favorite, right? Because now we are seeing a lot of this chatbot applications, chatbot apps, right? Everyone is launching new chatbot applications, but we really want to understand how it works and why it's becoming more popular in inferencing world, right? So I just quickly did is I searched on LLM Inference on Google, and if you see AI overview, it shows me and give me a quick definition of what LLM inferencing is, right? Now, I don't want you to read this entire thing because that's what I'm going to explain, but I want you to focus on this red circle, or I would say ellipse, whatever it is. And basically, inferencing is nothing but that I understand is prediction, right? So we will see how it predicts, how it works, and what different technologies is used to predict this text and the output that you see on your screen, right? So just keep this in mind that prediction is something which is related to LLM inferencing, right? And then we'll take it forward and then try to understand what it is. So I'll try and use more pictures, not text, because I think text is expensive and you will learn why it's expensive, right? So if you think about any system, computers need some kind of input from human, and then they will give you some output, right? And I think this is the same case with large language model, the LLMs, right? You give it an input, it processes it, and then it gives you output, right? This is very clear thing. Every system that has been built over the last 50, 60 years follow this model itself, right? The input, process, and then output, right? So we'll take this forward and try to understand how LLM does this processing and then gives you the output, right? So if you're using ChatGPT, I'm assuming everyone is using it, right? So what you do is you enter some prompt, like whatever your question is. Maybe you're trying to understand some, or maybe you're trying to writing some PRD, trying to write some blog post or anything else, right? So what you do is you give it a prompt which will be given as an input. It goes to LLM and then it generates some text as an output, right? So input, process, output. That's the whole idea of any system that involves hardware and computers, right? So give it an input as a prompt, LLM processes it, and then it gives you output as a generated text, right? Now you might have seen this, that whenever you interact with any of these chatbots like ChatGPT, it try to predict the next word for you, right? So for example, if you're just saying the sky is, and then you press enter, it will try and predict the next word for it. And this comes from its prediction engine, which is LLM, which is trained on huge amount of data sets, right? So answer can be the sky is blue, the sky is clear, the sky is usually something else, the sky is the, or something like that, right? So what it does is it try to understand your input. So this thing is the input to the LLM, and then based on its training data, which has been trained on millions or billions of parameters, it will try to predict which will come next as the next word, right? So basically, everyone might get a different answer, right? It's not a guaranteed that you will get blue, always blue as the output. So go ahead and try it out on ChatGPT and comment what you are getting as output, whether it is clear, whether it is blue or something else, right? So what it does is it's basically try to calculate a lot of mathematical calculation goes behind the scene to understand what will be the next word. And that's all the prediction thing that it does, right? So think about LLM as a prediction engine. Is that's what I feel, that that's how I understand this LLM things. It's not like that, you send a query, it goes to backend, then it returns some output, right? It does prediction, it does generate a text, and that's why the cost is going higher and higher for all these chat LLM applications, right? So we'll take this analogy and then we will move forward and try to understand how actually LLM generate this text, which is called inferencing, right? So think about this. You enter three words, machine learning archive, or the sky is blue, right? So all of these single words will be translated into a token, right? So this machine will be a one token, learning will be a one token, archive will be a one token, and this exclamatory sign is one token. So every time you enter some text to this chat GPT, it what it does is it takes the entire input prompt and then it try to break down into a small tokens, and tokens are basically these sentences, like words, I would say, right? Not a sentence. This is a sentence. This break this into a smaller tokens. So every text in the sentence is broken down into a smaller tokens. And then what it does is it assigns some numbers like token ID to each of these words, because computer don't understand text, they work with numbers, right? The binary calculation and all of those things. So every time you enter something, it breaks down into token, which is called a tokenization process. So I'll not go into more detail of like how does it calculates and how does it works, because most of us are product managers and we understand like customer perspective. So we'll just try to understand from the user experience perspective, right? Definitely you can go ahead and learn more about how it breaks all of those things. But this is the idea, that when you give an input to LLM, it breaks down into a smaller token, and then it assigns some token ID to it, right? And then based on this token ID, it try to predict the next word. Okay. And to predict the next word, that's where the mathematical calculation that I mentioned happens behind the scene, which is called matrix multiplication, right? So every text is translated into numbers, and then these numbers will be, put together and try to predict which will come as a next number to it, which will be more relevant to the user, right? So the sky is blue might have some numbers assigned to it, and then these numbers will be, somewhere in this kind of like mathematical matrix format, and then it try to predict the next word out of it. And this matrix multiplication takes a huge amount of computing power, right? Because uh, you know and that's why we will go into understanding this inferencing, how does it generate, what it needs from the back end. But just think about it, that when you enter something, it translates into token, it assigns some numbers to it, and then it does some metric multiplication and then predict the next word out of it, right? So just picture this in mind, right? To do this matrix multiplication, you actually need a GPU, right? Because the GPU is very good in parallel processing, right? So that's what we will see next. You can definitely do matrix multiplication on CPU, but it's much slower as compared to GPU, because GPUs are built in order to do some parallel processing, right? That's what we will see. So if you look at the CPU and GPU, CPU, so if you have like Intel CPUs on your machine, you will see that you will find fewer cores into it, right? So every CPU is divided into multiple cores, right? So if you have like i6 or i4 or i9, you will find that you will have like multiple cores to one CPU, which has like small number of cores, right? Which is good for normal processing. But when it comes to mathematical calculation, which is huge number of calculation that's going on, if you do that on GPU, it is much faster as compared to the CPU. So if you look at this picture, CPU has fewer cores, GPU has so many cores, smaller cores, and the smaller cores will be used for parallel processing, right? So when you do some metric multiplication, it divides that into a smaller chunk of task, and then it gives it to GPU, and then it tries to calculate it, and then aggregates it and give it back to the GPU for single processing, right? And that's why think about it, that CPUs are basically built for sequential processing, whereas GPU is built for parallel processing, right? And that's why you always need this GPU if you want to run LLMs, or if you do some inferencing platform, if you're trying to do some model training and all of those things, because that does requires a lot of parallel calculation, and to do this parallel calculation, CPUs are much slower. And that's why keep hearing this word that GPUs are expensive, GPUs are needed for LLM, and you need GPU. Without GPU, you can't do like much faster inferencing for users. So every time you enter something on chatbot like ChatGPT, It goes to the backend to the LLM, and then LLM runs all of these calculation on GPU in order to predict the next text. So that's the whole reason why you need GPU for LLM processing, right? Now, like I said, it needs multiple cores. So CPUs have very few cores, like multiples, but GPUs have thousands of cores, and that's why if you want to run LLM inferencing on any GPU, you will have to buy this expensive GPU because GPU comes with a lot of cores, which is extremely good for parallel processing and fast inferencing. Now, like I said, every
Um,
time yeah,
Maybe
any
one question, Shamsher, since we are in the context of that, is there more context you want to give on the stronger versus the weaker cores?
Yeah, so basically, when you say stronger and weaker cores, it doesn't make sense to do all of this calculation on CPU because CPUs are good for sequential processing, one by one task. You give it a task, it does some processing on it, and then gives you an output. But it comes to GPUs are good for parallel processing, and that's why you need a very smaller cores, which is weaker, but that's really good in doing a small calculation. So when we say weaker code does not mean that it cannot perform well. It basically means that for parallel processing, you will have to actually divide that task into multiple smaller tasks. So I don't know if you've learned that divide and conquer rule in data structure. That's basically how it divides this smaller, like big task into smaller one, then gives to this smaller course and try to get the answers from this code. So it does not mean that weaker core means it's not a performant. It's basically a performant, but it is capable of handling thousands of calculation in a smaller course. So that's the whole idea for this smaller and weaker course, I would say. So I don't think so weaker is a good word. I think smaller cores might make more sense when it comes to GPU and parallel processing. Awesome. So yeah, and that's why I think to do this LLM inferencing and model training and anything that relates to AI, you need different types of GPUs, and this is how the GPU actually looks. If you're not aware, I think you might have already gone through a lot of Google search and try to understand how this GPU looks. But if you are not aware, this is how H100 and B100 GPUs look like. And this is where all the LLM inferencing and all the calculations are happening behind the scene, right? So every time you write some text, it goes to these kind of GPUs that handle like that calculates this prediction for the next text, and it try to give you the answer in the same format which you are expecting, right? So in order to run a large language model, basically anything that relates to more parameters, right? So if you heard about GPT 120 billion parameter, right? It's recently OpenAI released this. They have two kind of model. One is 20 billion parameter, and another is 120 billion parameter. There's also a DeepSeek which comes with 670 billion parameter model, and then there is Kimi K2 which comes with almost trillion parameters model, right? So if you want to run those kind of large language models, you really need a multiple GPUs in a to run this large language model, because you cannot run this large language model on a smaller GPUs, right? And that's why this single GPU actually can't run the entire LLM. It needs like multiple racks. So the picture that you see here, every rack here, this is entirely a rack, but these are all GPUs installed into this rack, right? So this will help you run one large language model, something like 670 billion parameter or 1 trillion parameter model, right? There are different ways you can try it on your machine if you want to try it out. So I've recently bought this M4 Mac Mini where I was trying to experiment with LLM inferencing locally on my Mac, but it has only 32 GB RAM and 21 GB VRAM, which is very limited. And max it can run is 20 or 24 billion parameter, and the response that I receives is very slow. Like it takes almost 10 seconds to get the response, and every token was very slow to respond with these things. And that's why if you want to run a large language model with like more billion parameters, then you definitely need a lot of GPU power behind the scene, right? Now, like I said, Kimi K2, which comes with $1 trillion parameters, that actually requires multiple of these tracks, right? Because again, that is a huge number that takes a lot of memory bandwidth and VRAM, and that's why you can't even run that on a single rack. So that means you need multiple racks, which is kind of like I would say a GPU cluster, right? So every time you interact with ChatGPT, that's inferencing, that goes to these kind of different servers to calculate your next prediction, right? And the larger the parameter model is, like 670 billion parameter model, the better the prediction will be, right? And if you try like 7 billion parameter model, maybe like Llama 7 billion or something, you will see that the response is very short, or maybe it's not the output that you're expecting, right? And that's why when you go and ask something on chat gpt, it gives you a proper answer with formatted things and then the exact things that you are actually looking for. So previously you used to just do a Google search, and then Google search used to give you a lot of links, and then you have to go click 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 and then try to figure out what I was looking for or what you were looking for, right? But now with this all this chat gpt in every tool, what it does is it gives you all these relevant answers directly on the chat interface itself, right? So that's inferencing. Every time you ask something, it goes and it collects all this information from the huge parameter model, and then predicts the next text, possible text, which will be relevant, and then it puts that together into a proper simple answer, and then it gives you a response. So now going forward, if you interact with any of the steel tools, you enter it, you will know that this is basically inferencing that is happening behind the scene. And every time you enter it, it goes to these kind of GPUs and GPU clusters to get your answers, right? And this is how I started learning about this things almost 2 years ago, when I started interacting with ChatGPT, when I heard first time about LLM. So I'm not from AI ML background. I was mostly on the Kubernetes and cloud as an engineer, and then I moved into product management. And the idea of product management is to simplify these things, right, for our customers to understand. And that's the idea. That's how I started learning more about it, and that's how I try to break it down into a smaller things so that it will be easier for our customers and our engineers to understand what's going on behind the scene. So we are building something similar, and maybe by November or December, you'll see more exciting stuff from NeevCloud. But this is how everything happens behind the scene, right? Now the first part is complete, which is understanding the inferencing. I hope you've got the idea. If you have any questions, feel free to.
Shamsher, there is one question, probably you can see it on the screen.
Yeah.
While you probably want to kind of give a summary of Mragank has a question of if you can explain the term parameter and is it same as tokenization? So do you
Yeah.
want to kind of like, yeah.
Sure, sure. So basically, when you say parameter, if you see, you can think about that as a token itself. So cost will be one token, off will be one token, running will be one token, inference will be one token, and all of these tokens basically makes up the parameter, right? So when you learn about like 7 billion parameters, that means those LLMs are actually trained on these different combination of text, which is basically a token, which makes up the parameters, right? So the more number of parameters that you see on the large language model, basically it means that it's more efficient and it will be able to predict your next text much better than the small language models, which is like 7 billion or 3 billion or 1 billion parameter model. So all of these parameters are basically this text which the LLMs are trained on. And if you go and look at Hugging Face and go to any of the specific LLM, you will see they will be having some JSON file, .json file, and then when you open it, you will see a lot of text, in a one line showing that these are the text that LLM is trained on. So that's basically a parameter, and parameter basically makes the LLM much stronger. So the large number of parameters, the better the LLM will be. I hope that answers the question.
Yep, I think we
Awesome.
can move forward.
So yeah, I think the first part is complete, which is basically understanding what inferencing is. So you enter the text, it goes to GPU, it calculates the next text, and then it gives you a response. That's basically an inferencing, right? Now, for product managers, it's very important to understand the cost aspects of these AI products, right? Because every time you build something, you have to make sure that it has some business values and it is easier for our customers to use, and they should be able to pay for it, right? If they don't see the value out of these products, they won't be paying you, right? They might be using some different products which is giving you more, like which is giving them more value, right? Now every time you build AI products, you will have to think about cost from the beginning, right? Because this inferencing things takes a huge amount of GPUs, which is the GPU cluster that you see. And right now, what you can do is you can use the OpenAI APIs to build AI products, right? But you will have to pay for every token. So there are two types of tokens that comes into LLM. One is input token, and the other is output token. The same thing that you have seen, right? You give it an input and then it gives you output. So prior to AI products, you have never been charged for this input token. So anything that you want to pass to backend, you just send a, API request. It calculates and fetch some data from database, and then it returns. So the pricing used to work was based on API call, number of API call, not on the data sent and data received, right? But with AI product, that's completely changed, because every time you send AI some text, which might be you copy some blog post and then give it to it and then ask it to summarize it, right? So that blog post might have maybe 500 words, 1000 words, and each of these words will be broken down by GPU, and it needs some processing and mathematical calculation to summarize that blog post, right? And that's why even the input text is also costly for AI products. So when you build an AI product, you really have to think from the beginning that what will be the context for input text. So context is basically the limit that you want to enforce on the number of input parameters, like how much users can send. So if you look at GPT, initial version of GPT, they used to allow only like 500K or something, but now it's increased to 128K of this input context. And if you look at Gemini, they support 1 million input context. That means you can actually book that, put the entire Harry Potter book into it, and then it will summarize you for your input, right? But to do that, it also costs you for input text. Also, you will have to charge your customers. So that's the whole idea, and that's why if you are building AI products, you have to think from the beginning about the input token and the output token, and based on that, you will have to charge your customers.
Yeah. Shamsher, there are already a few questions, but maybe a couple of things, and this is something which I very commonly hear, right? A lot of people get confused, and this might be a good exploration, the explanation that you can give.
Okay.
What is the difference between training, inference, and fine tuning, for example, right?
Right.
Because each one of them also has a cost implications, right?
That's true.
So if you
That's
could
true.
just unpack that, and there are also already a couple of questions, maybe we can go through that before we also go into deeper on the costing part of
Sure,
it.
sure. So if you talk about training and inferencing and fine tuning, these are three separate things, right? But everything costs you, everything requires a GPU. So let's talk about training first, right? If you want to use any LLM, large language model, you have to train it on a large data sets. Like I said, like cost is one text, running is one text, inference is one text, right? And every company, not every company, very few companies who are actually building these large language models, they need to train on these different text, and that's called the training process of LLM, right? So what they do is basically they give a huge number of data sets, which can be a different combination of text or combination of examples, or different sentences, maybe blog posts, maybe books, maybe images, and they consider that as a data set, and then they use their ML model to train on these data sets, right? And that training actually happens for like 3 months, 4 months, 6 months, depending on how many parameter model you're actually training on, right? So think of it as teaching your AI about the real world examples of this text, right? So we human understand this text, but computers don't understand text. They understand the numbers. So you will have to feed them with text, and then it translate that into numbers, and then it try to understand and predict the next word. So that's the process called training, where you give it a text, set of text, to understand the context, to understand the words. Maybe like we said, the sky is, so it will give them multiple text data sets, that sky is blue, sky is clear, sky is dark, something like that. So these are data sets on which the LLM models are trained. Trained basically means training. So if you think about athlete, right, they have to train on the field for a certain period of time, and then only they will go and run in the competition, right? Similar to say, it's the idea is almost the same. If you want to use any inferencing platform, you have to have this trained model, which is large language model, and that training requires a huge data sets. But the important point to understand is training happen only once, right? And then inferencing happens 24/7, right? So if you use Chat GPT, that Chat GPT took almost $100 million to train GPT-4 model, right? That's the price that they will have to pay, because it requires a lot of GPU power in order to train these models. And then now they have to pay more cost because this inferencing is almost continuous 24/7. So everyone from around the world is using ChatGPT almost every second, I would say, right? So training happens for a small period of time, like 3 months, 4 months, or 6 months, and then inferencing happens continuously. Now, if you understand training, when it comes to trained model, that model will be used for inferencing, which is like asking questions and generating text. So that's called inferencing. And inferencing happens almost every time, like 24/7. So you ask it a question and then it gives you a response instantly, immediately, I would say. And user don't wait for like long period of time to get the answers, right? If you're doing some deep research or something, that also involves inferencing in the background, where it goes and tries to collect different information from different sources, and then it collects the text, try to answer that properly into a single summarized way, and then it gives you a data on the chatbot response. That's basically an inference. Now, when it comes to fine tuning will be done less frequently. Basically, you can use this large language model and then you come up with your own data sets. For example, maybe you want to train it for law firm, right? So law has a specific terms that they used in their day-to-day life, right? So you use this large language model and then you come up with your own data set, which is specific to any domain, maybe healthcare, maybe law firm, maybe something else. And then you use the base data set and put that your data set on top of it in order to fine tune the large model. And then the output also goes through the fine tuning training basically. And then the end result is basically the fine tuned version of this LLM. So next time when you ask it a question related to law firm, it will answer you very accurately as compared to the large language model. So large language model is trained on almost all the data sets. But if you want more accurate results, if it is related to any financial data or something, then you will have to come up with your own data sets, which is specific to your domain, and then you can fine tune it. And maybe you can consider that as a SLM, like small language model or something, right? So model training, inferencing, and then fine tuning. This is the continuous process that happens, but fine tuning happens very rarely if you want specific details related to any specific domain. So I hope that answered the question.
Right, right, right. So basically, if I summarize, in the AI world, there is a continuous monitoring, measuring,
Yeah.
improvising that happens that helps you to keep the responses which you are getting, especially from your LLMs,
Right.
to be very contextual and relevant. And that
Right.
is where you continue to do these aspects, right?
That's true. That's true.
Yeah. I see a question from Ayush. Let me know if this is something you want to take now or you want to kind of take it
Yeah.
later.
Sure. Sure. Sure.
He's talking about, can you please tell me some techniques for SLM models to integrate with models with hardware VR devices or smartwatches?
So you can use, so if you're using it on hardware, small hardware devices, I would recommend you use Liquid AI's a small language model. They have billion parameter model, which is very efficient. I've tested it locally on like on my Mac M4, and I think this 1 billion parameter will be sufficient to put on a small hardware devices. Now, when you talk about AR and VR, that involves vision model, right? Which means it needs to understand everything from the real world pictures, right? That's not trained on text, that's actually trained on images and videos, real world images and videos. Which means when you want to ask something, so you're wearing a goggle and you're asking something that you see on the screen, right? So what is this cost of running inference, or maybe what is this monitor is built with? So it is built on LG, so it will see the picture of monitor, and then it will understand from its trained data on the vision model and try to answer you, right? So I will recommend, if you're looking something for putting it on a small hardware device, maybe Raspberry Pi that I've done previously, you can restrict that to 1 billion parameter. That will be considered as small language model. And the vision model is what you will require when you want to understand something for AR and VR application. So I hope that answered the question.
Yeah, sounds great. I
Awesome.
think, Shamsher, let's go ahead and finish the agenda for the
Yeah.
session today, and then
Oh.
I think we can take more questions towards the end because I
Right, because
definitely
we are
want to make
already like
sure.
12:35, so I'm not sure if we'll
Yeah,
be able to. So I'll quickly run through this because this is something you will have to really consider when you're building AI products, right? So I hope you have seen this tweet. So we use this AI application, and when it responds to you, you also, you are really polite, and then you are saying thank you, and then it also gives you some, answers behind the scene, which basically depends on your previous context. That's so the question that you were asking. So this guy said thank you, and the chat GPT responds, you're very welcome. If you ever need another poem explanation or just curious, chat, I'm here. So that means this guy was asking poem and asking for some poem. So when you just say thank you, it also needs some computing power to understand your previous context, which was before this thank you, and then it generates this, you're welcome answer, right? Which is again like based on your context, so that it tells you exactly what you're expecting, right? So one guy actually asked that how much electricity and power that OpenAI might be wasting just because people are saying thank you and please, right? And he said tens of millions of dollars, right? So because thank you also requires AI to generate some response, and these are can be considered as tokens. So your will be one token, very will be one token, welcome will be one token, this emoji will be one token, and now you see here you might be seeing like more than 25 or 30 tokens, which again cost AI some GPU compute and some electricity and some power, right? Now you can understand that everything that involves AI has to go through the cost implication. Right? So I'll just go and show you some statistics numbers that I've found recently. So basically, this ChatGPT OpenAI has approximately 500 million users. I think it was until April 2025. So I think 4 months ago, 5 months ago. Now the user base might have increased. Now just imagine this 500 million users. They are, every time they receive some answer, they say thank you, right? That means even for one person, they will have to, if you consider like one person $1, then they'll have to, just for the thank you, they might be spending $500 million, right? Just for the thank you things. Now, some real statistics that I found based on inferencing monthly cost. So if you see, these are number of daily active users, and this is basically per month cost. And if you see, depending on how many users it is handling, the OpenAI, so the blue is OpenAI, the 20K users, monthly or daily active users, is actually costing OpenAI approximately $60K, right? So multiply by 20K, now they have 500 million users. Multiply that, and you just imagine how much cost they might be incurring for responding to your free queries. So now you go to ChatGPT, you type anything that you want, it gives you an answer, right, for free. You can definitely go and buy their plan, but they are still running not in a profit, or even on the paid models, right? So 20K users into multiply by 500. Now imagine the cost that OpenAI has to go through just to generate this text and give you a response. And that's why if you're building AI product, you really have to think about what is the input text that we want to limit for users, and what is the output text that we want to give it to the user. So that's the thing that you will have to consider. Otherwise, you will be incurring a lot of cost, and you won't be able to get it back from your users, right? You will have to restrict that like $20 per month. That's the bandwagon going on in the LLM or AI world, where everyone charges you $20 per month. But you have to really look into, are your product AI products is profitable with that $20 model, right? Now, when you think about, I think I've already answered this, but I want to also understand, like, also explain what is the factor that considered during the inferencing cost, right? So there are three factors basically, right? The first factor is the size of the model, right? So this GPT-4, it has approximately 1 trillion parameter model, right? So when they started, it was BERT, which was 345 million parameter model. That means it has been trained on 355 million parameters. Similarly, GPT-2, 2 billion, GPT-Neo, Turing, GPT-3, and now GPT-4. You're currently using GPT-5, but they did some trick, which I'll explain later, which actually reduces their cost of inferencing, right? So GPT-4 comes with 1 trillion parameter model. So inferencing basically depends on the size of the large language model that you're currently using for your AI products, right? So that's the first factor, right? The second factor is token count. Like I mentioned, all of these different LLMs comes with a different size of token limit, which is basically input token and output token, right? So how much they can accept from users and how much they'll be able to produce based on the input context, right? So all of these models comes with some limit, like 120K, 128K for GPT-4 model. Similarly, all of these models have this specific. So like I mentioned, Gemini actually comes with 1 million context window, which means they can actually accept this context like a entire Harry Potter book, and then it will be able to summarize you very properly with this, right? So that is the second factor that considered during the inferencing cost, which is token count. The last one is concurrency, which means how many users are simultaneously accessing that large language model. So if you are asking from to ChatGPT, you are the only one person, but at the same time, people around the world are also using the same interface to ask ChatGPT, right? So the next inferencing cost, that factors that will be considered is concurrency. How many users are simultaneously using it? So for example, 120 120 billion parameter model, if it is deployed, I think 10 people can simultaneously ask it like questions, right? But increase that to 500 million. That means it needs to answer almost 500 million people simultaneously from the same inferencing platform, which requires a lot of GPUs to respond, right? So these are the three things which will be considered or factored when you want to provide some inferencing platform, right? Now, again, this is where we jump in. This is where we put our efforts in understanding what will be the cost that might affect my AI feature that I'm giving it to our customers, right? So there might be different things, but I've taken a couple of examples, right? So I think this is what recently GPT-5 OpenAI have done. What they did is with GPT-5, they've actually built this router, right? So every time you ask, it tries to figure out whether the answer will be smaller or the answer will be larger. And depending on that, it actually redirects it to different models. So maybe it redirects to GPT-4. If the answer is very small, which requires 350 million parameter model, it redirects that to a smaller model. And that's the way the GPT-5 or OpenAI is actually saving some cost. So people started talking about it's not efficient, it's not answering it properly. But imagine 500 million users were costing a lot of money to OpenAI, or instead of giving more powerful model, they actually built this router into GPT-5, which redirects the answer to a specific model. And I think if you are building AI products, this is what you will have to consider. So think of this: GPT-4 is large language model. Mixtral 8 7B, which is 7 billion parameter model, is basically an SLM. Right? So anything between 250 million to 7 billion parameters can be considered as a small language model. Anything above 7 billion parameter can be considered as large language model, right? So if you have a smaller answer, you will redirect it to a smaller model. If you want, if you are expecting like writing a complete PRD with all the competitive analysis and metrics and all the details of what problems you are trying to solve, maybe come up with epics, user stories, and all of those things, that requires large language model because it needs to generate a lot of text, right? So this is the thing that you will have to consider when you are building AI feature into your product, or when you are building any AI product from scratch, right? The other thing that you will have to consider is when you are giving some suggestions to your users based on their input, you will have to figure out whether you want to give them like multiple suggestions or whether you want to just give them a one suggestion, right? So each of these suggestions needs involves a token, and it needs some processing from the LLM, which requires GPU, which requires cost. So if you're giving them three different options, then it might cost you more. It's good for users, but it might cost you more. So you will have to decide how many different versions you want to give to user, whether for their suggestions only one suggestion will be sufficient, or more suggestions is required. So that's something PM have to figure out and then decide, and depending on that you can decide the cost of your AI product. This is just another example. I'm saying that if you are building some autocomplete functionality, which might require LLM or which might not require LLM, but if it is requiring maybe some things that you want to have a better experience for your customers, you can build some autocomplete. But then you'll have to also decide whether you want to give this suggestions real time, or whether you want to just put that as spaces or tabs, and based on that you will give them a suggestion. This is just an example. It's not necessary that you need LLM to build some of these autocomplete things, right? So some of these factors that you will have to consider when you are building your AI products, right? Now, one of the example that I'm using Perplexity a lot, and I've learned that when they launched this product, it was free, and everybody started using it, but then it started costing them a lot, right? So they decided to launch this pro model where they might be charging like $20, $25 to their customers, and that's how they at least started generating some revenue for this inferencing things, right? But still, it's very less because $20 will not pay the cost of running GPU or the cost of GPU itself, right? So another example is OpenAI. They actually released this API, Open API, which you can use to build inferencing platform or AI features into your product, right? So they also charge you based on token, so input token and output token, how much you're sending it to them and how much you're getting in response. They also launched this Go model into India, which is almost 499 per month, just to generate some revenue from Indian customers, right? Because Indian were asking a lot of questions. They are spending almost all the time on ChatGPT for almost everything. So they started charging that out. I think they have more than billion users from India. So I think it will be a good strategy to start charging them if they are really using it a lot in their day-to-day life. Now, I think this completes second part of our session, which is the first was inferencing. The second was the cost of running inferencing. Now, the third is what is the ROI of LLM, right? So before I jump into that, I'm going to see if you have any questions on cost of running AI.
I probably had one question, and I also see there are a few more questions which are there. Probably we can pick it up. But
Sure.
Shamsher, one question I had is that, especially like the whole aspect of optimization, right, for one of the products which I was doing, and that is when we had a revelation that we assumed that we are going to have so many concurrent users, and then we started seeing our AWS, the we were
Bill.
basically using these things, and our
Right.
bedrock and our
Right.
token bill just went
Right.
without any
That's true.
intimation, right?
That's true.
So my
Yeah.
question was that if you are using only OpenAI, then probably it gets you the routing services to say that, okay, when do you call a reasoning model versus when do you really call a, let's say, a
Yeah.
GPT-5, right?
Yeah.
But if I really want to use, let's say, for simpler questions, if for example, if I have a chatbot, for simpler questions, I want to probably call from different vendors.
Hmm.
Are there any kind of managed services which gives you a rerouting, or should I, as a product manager, need to bake that routing for different questions to different models? I have to do that as part of my development.
I think that's a good point because that's where we will save a lot of cost. And some of the good managers, product managers, have already built this application for us, other product managers, so we don't have to worry about thinking about cost. So there is a service called Open Router, which
Okay.
actually helps you redirect this to a different model. So if you're, like you said, reasoning model or image model or video model or maybe large language model or SLM, right? So this Open Router have built this service where depending on the input context or input tokens, it decides what type of different LLMs or SLMs or vision model you need. And depending on that, it routes the request to a different model. So all you have to do is register on their platform, get the token, and then specify how many different models you are using, and then just connect it to your application. And when you ask, when your customers are asking questions, it automatically takes the heavy lifting from us, from a developer and from product managers, and it takes care of deciding based on the context where exactly I need to reroute the request depending on the input and what type of output the user is expecting from it. So we don't have to do anything. We just have to use their service and build this. There are other platforms that have built the same capabilities. And I think the GPT-5, they've done the same thing, right? So
Right.
we don't have to worry about choosing where to route the request. We can use these services and build application on top of it.
Got it. Thank you, Shamsher.
Yeah, perfect.
One question from Mohammed is why there might be a vast difference in cost between these companies. I think he's talking from a cost of inference perspective.
Hmm. So like I said, inferencing requires a GPU power, which means for every input and every output, everything runs on GPU. So if I give an example of a 100 GPU, it can generate 1 million token, 1.2 million token per hour, right? Which means you can use one GPU for 10 or 15 users, right? And then 1 hour when that GPU runs, it needs electricity, it needs cooling, it needs power, right? And obviously you have spent millions of dollars into buying this GPU. So that means it needs some, like, you need some kind of return out of it, right? So that's why every time you ask it a question, it needs a lot of cost that goes behind the scene that users don't understand. What they care about is the answer that I'm expecting, right? So every GPU needs to run some power, electricity, cooling, and the cost of GPU. So that's why this LLM request cost you a lot.
Got it.
Yeah.
You spoke about one example of Perplexity where they gave it for free, and then based on their inference cost, they actually started came up with the pro version.
Right.
Are you aware of any other examples where the company changed its pricing or the product strategy itself because their inference costs were going too high?
Yeah. Yeah. So another example that I've been using a lot previously was Claude AI from Anthropic, right?
Uh-huh.
So they were very efficient in generating the code, like Bash script or any programming language code, and they were also very efficient in generating the UI elements. So I used to use that for generating some prototype for our application, and then I used to give that to our UX developer. Then just for understanding of how we are thinking about the experience of the product, right? And then I saw that they did two things. They put some limit on the number of requests that users can use, right? So
Hmm.
you ask 4 or 5 questions, and then you will see a message saying that you reached the maximum context limit, right? So now you
Right.
can't use it. Either you will have to pay, or you can come after 24 hours to use our product, right? So that's the first thing that they did. They also added this pro plan for their services, and they increased it to like $20, $25, or $50, depending on the which type of premium plan that you're using. And almost every AI company which are providing these LLMs, they need to get some returns from these models because they have invested a lot of energy and power and money into training these models, and they need some kind of ROI out of that. So that's what we will discuss now quickly. I don't think so we have more time left. It's almost 7 minutes left. So what we'll do, I'll just quickly walk you through if you're a product manager or a builder, how do you think about return on investment, right? It's not that you put $1 million on GPU and you will expect that I will generate $10 million out of it, right? There has to be a different way of calculating the ROI. It does not mean that it's always a money. It can be anything from saving users more time, giving them a better experience, or helping them find whatever they are looking very quickly, so that they don't have to spend a lot of time searching this information on the web, right? So we will talk about the last topic, which is ROI of LLM, right? So basically, if you're a PM building a product, AI product, the first thing that you will have to think about is what is the business value that you will generate if you're building an inferencing platform, right? So the business value that we will get is for every dollar we spend on inferencing, how much value we can generate or how much business we can generate for the company, so that maybe we at least get $2, $5, or $10 per user per request, right? That's the idea for calculating the ROI. So if you put that into a simple formula, it's basically value delivered to the user divided by cost of serving them, right? Now, if you do that calculation for inferencing, which is the formula that I found in the morning, is basically business value minus cost of inferencing divided by cost of inferencing into 100. That's how you will be able to figure out and calculate the ROI. But like I said, it's not always the money that you will get as a return from your users. It might be the amount of time you save to your users, but definitely you don't want to go into a loss business. You want to generate some revenue, so you will have to then calculate the ROI depending on not just the money, but adding user experience and value to the customer experience, right? So just to give an example of ROI, so let's take an example of company A. They built a support board, right? So every time you buy something from them, they have any problems, they will ask to the support boards instead of calling a support agent, right? So they use GPT-4, like inferences cost is approximately 100K per month, right? And then instead of putting uh, 20, 25, or 50 support agents, they actually use this support board to answer it very quickly, to clarify some of the questions, to doubts, and when my delivery is coming in, if I have any fault in the products that I receive, I'll just share an image and then it responds quickly. So they actually, instead of hiring more, they actually save 250K per month for that the support agents, right? Which means the net ROI will be approximately 150K, which is still a positive experience, right? So you save 250K and then you only spend 100K, which means your return is 150K, right? Now take an example of company B. They just built a chatbot because it's easy to build, right? OpenAI use their API, build a chatbot, and then put it in the market, right? And then that is actually costing you 50K per month, but you're not adding any value to customers. So it's not generating any revenue, which means your ROI is negative, right? So this is how you try and calculate what is the ROI of my product, right? Now, think of it as a seesaw, right? So on one side, you have cost of GPU, you have cost of inference, cost of input token, cost of output token, cost of electricity, right? That's one side. The other side is how much time you're saving to your customers. So if they're booking a flight and they use your AI products to quickly search for what they're looking for, and it helps them book the flight within like 2 minutes or 3 minutes, right? So they know their timing, they know when they want to go, they have their own preferences. They put it on your AI product as a text, and then you quickly return the output and give them the exact thing that they're looking for. That's the time saved for users, right? And then the other side also consists of new revenue opportunity and also like a better user experience, right? So if you give your user a better experience from your AI products, that means you create a stickiness. That means they will come to you again and again, which means they will generate a small revenue for you. But if you're not able to generate a better user experience through your AI products, that means it will cost you. Users won't come back, and then you will have to keep adding features, trying to convince user that our product is better than another product, right? So yeah, one side is cost of GPU inferencing, the other side is the value that you add. Now, the PM job is to ensure that the other side, which is not the cost that we involve, but the experience and value that we create for users is increasing. And that's how you will generate the ROI, good ROI from your AI products. So I think that's all from my side. Uh, we only have 2 minutes left. I thought we will be finishing 15 minutes early, but I think it should be fine.
Yeah, it's good. We
So,
have had quite a few questions. So
okay, awesome.
yeah, thank you, Shamsher. There are a few questions left, which probably we can take it in the next few minutes.
Sure.
One of the questions from Ashutosh is when a user starts to ask deeper conversation in between a casual chat, then will the router shift the model or stay with the initial version?
No, it shifts the model because router don't care about how users are shifting. They only care about input text that it is receiving, right? But there are some intelligent routers which also understand the text. So if you are putting question and you are giving an example with like a huge data sets, right? It will not route that to a larger model. It will try and see if smaller model can actually process it, and then based on that, it redirects your request to a smaller language models.
Awesome.
Yep.
A question from Bhaskar is that how much more does it cost to go to a larger model for the same token input size?
It's large. It's a huge because the large language model requires a lot of computing power. So they will charge you more depending on how much input text you are providing to it, and that's why you have to kind of use these kind of routers to save the cost, right? Now, I think I forget to share my product, which was about. So I'll just quickly share and then show it to users, and then I think
Sure.
they can go ahead and try it out and they can understand. So this is the product that we are building, which is called AI.ml. So you can just go and search AI.ml and you will see this platform, which is a fast inferencing platform that we built. It's still in beta. There are a lot of things that we are improving currently, but I think this gives you a better experience of what inferencing is. Whatever we have learned right now, you can try it out here. So all you do is just click on get started, quickly use your Google account to sign in, and then you know you will see everything that I talked about. Basically, the tokens, input token and output token. So this is the thing that you see. You can enter your prompts here. You can select the different models out of here, like DeepSeek and all 671 billion parameter model that I said. You can choose the smaller model, 9 billion, right? Different models that you can select, right? If you go to text to video, you will see the estimated token depending on what is the resolution that this video will generate. So all you do is you enter the prompt here, and then it uses this vision model to generate the video for you. You will get some free credits like $10 credits to use this product, but you will be able to figure out what will be the estimated cost and what will be the estimated token from this model that I will put in, right? So if you click 4:3, you see the token size increase. For this, the token size is increasing, right? So depending on the resolution, it actually changes the cost and the estimated token, right? So video requires a lot of tokens to generate it, and that's why this is the output token basically, right?
Hmm.
And this costs you different things. So you can just go play around with it. You can also do image to video where you can like, put the image. This will be used by AI influencer which are creating like TikTok and Instagram reels to generate some videos from it. The cost is very low. You get $10 free credits, and then you can pay based on your usage, right? The important thing is you get to understand and use this with the inferencing platform that we have built. And I'm happy to receive some feedbacks from you. You can directly tag me on LinkedIn or basically ask any questions if you have. But I'll encourage you to try it out and provide some feedback.
Awesome.
Yep.
Does it also, if anybody has set up their own SLMs, does it also works with that?
Uh, so currently we are not giving you the ability to choose your model. We give you some pre-built models, but that's
Okay.
the next thing that we are building. If you have some fine-tuned models for your company, you can just upload that as a data set, like as a external LLM from Hugging Face or some, and then you will be able to search and ask questions based on your own LLMs, right? So that's the thing that will be coming for the next release, I hopefully. Let's
Awesome.
see. Yeah. So
Awesome.
the platform name is AI.ml. Just go ahead and try it out and let me know your feedback.
Yeah, that would be awesome. And probably I can also share. Shamsher, if you want to kind of share any of your links and stuff like that, folks who may have questions and would like to, I'm just sharing your LinkedIn profile here
Sure, sure.
so that
Absolutely.
folks who would like to, connect with you. And of
Yeah.
course, there will be also a social media post that I will do
Yeah, yeah.
for folks to kind of listen into this video. But folks, if there are any last questions, if we may answer, I have also shared Shamsher's LinkedIn ID on the chat. Feel free to reach out to him. And Shamsher, before closing, one last question.
Yeah.
What is the most favorite model that you are playing around with? That something that you mentioned that earlier you were using Claude a lot. Does that continue to be your favorite,
Uh,
or
so
is it
so
different now?
So I actually prefer to run my own model on my own machine. I do
Okay.
use ChatGPT. I do use Lovable for generating a prototype. But
Okay.
in order to ask some personal questions, which is related to my own opinion and ideas, I run my own SLM on my own machine just to make sure that my data is private to me, not to OpenAI, because OpenAI uses your chat history and chat data to train their own model, right? And that's
Right.
okay. Like we are using it for free, so we can give them some of our own data, but it's something private. I run my own model, which is I've run llama model on my machine. I've run this liquid AI model on my machine. So I do have like all of those posts and a detail of how you can run these models on your own machine. So you can go to my Substack, and then you'll be able to see how do you set up these things on your own Mac machines.
Amazing.
Yep.
But do you really think, I mean, you are somebody who kind of is more on the compute side, a lot more technology driven.
Yeah.
But for a generic product management role, how much do you really think do product managers need to build their own SLMs?
I don't think so. I don't think so that you will have to build your own SLM. I don't think so. You should do it. Only do it if it is required for your businesses. Right? Otherwise,
Right.
there are a lot of open source SLM and LLMs which is coming in the market. You can use that. You can host on your own machine. You can connect the chat interface to it, which is open web UI, and then you can start using it. These models should only be built to solve the specific problems, right? Just like
Right.
product managers, we always focus on solving the problems, right? We don't want to create more problems because there are a lot of problems already in the market, right? So
Correct.
we should only use it or build our own LLM or SLMs when it solves the specific business problem. Otherwise, don't do it. It's a waste of time.
Makes sense.
Yeah.
Makes sense. Wow, the
Perfect.
hour just went very,
Yeah.
very quickly, and I know we are 5 minutes over these things. But
Yeah.
folks, thank you for staying with us. We saw a lot of questions coming from all of you.
Yeah.
Yeah. And I'm hoping I can already see some comments coming from Priyamvada. Folks, feel free to send more questions my way or Shamsher's way if you
Sure.
have more, and do share this with your circle, with your other product managers. We would love to hear what more you would like to, and we'll always be happy to bring back Shamsher
Yeah, sure,
to
sure.
talk more
Absolutely.
about maybe SLMs, talk
Yeah.
more deeper about any of the other topics that would be of interest.
Yeah.
Thank you, Shamsher, again
Thank you.
for spending time on a weekend and
Sure.
educating our listeners.
Absolutely. Thank you
Thank
so
you.
much.
Bye bye.
Bye.